obviously. And then you need to...
Go? Okay, this is the ESA 630, and every time that you switch on the machine is in editor page. Editor page is this button with the paper totally on the left. The main buttons here in the list are regarding the editor page, the menu, the manual page, that is the page that you need to enable every time that you need to switch on the machine or you need to put a new direct reference. This is semi-automatic page that I cannot enable because I am not the reference on the line scale in this moment. The other one on the side is the automatic page. This button is the list of programs. This other one is the list of dice, and if you press it 2 times appear also the list of the stample. Here we have a special page about correction, but this is something advanced for people who already has big confidence with the controller, because we can give influence also in the way how the system needs to make calculation about angle and X and R axis. We start from the beginning, and the beginning is how to make a new program. In the editor, normally there is a new program button. Then when you press, it starts from 0, from the first page, from the first band, and he asks you to set inside the rate of the plate. So when you touch it, there is also explanation. You must set what is the dimension of the bend that you are going to do. So my plate is long 1000 millimeters, and the thick, that is the thickness, is 1, for example. And now the next parameter is about how strong is my plate. And from 0 to 30 for the controller is aluminum, to 31 to 50 is iron, to 50 to more is stainless steel. So we decide to bend normal iron, that is 42. Then we're going to touch matrice, and appear the list of the matrice that I have charged in my controller. In this moment I have just drawn 2. And yeah, I can select one of those with fog in. I put it inside the program, and the same is with the stample. In the moment that I select one of the 2 stample, I press fog in. And then in this moment all the main data are loaded. Then I need to compile some values about the angle. For example, I want to bend 150 degrees. I make an automatic calculation for Y1 and Y2. I must remember that Y1 is regarding the feedback, that is the encoder of the spindle, that is the position of the bolt was making the regulation of the deepness of the machine, and Y2 is regarding the line scale. So both values need to be the same, and also that the machine to come up need to reach the value that is in the bottom, that center is described. So next parameter is about the x-axis. We set for example 200 millimeters. And here there is Teruk loop. Teruk loop is how many millimeters we want that the machine goes back after that we have reached the pinching point. Pinching point, that is the 180 degree on the 1 millimeter plate that I have set. So it can go 20 millimeters back automatically in the moment that we discover that are at the pinching point. The correction is always automatically enabled, and is a correction that the controller puts on the X value to have the 200 millimeter outside dimension. So as I go to 90 degree, for example, the correction become minus 1.1, and I remember that the thickness of the plate is 1. So normal iron is something more than the thickness of the plate to reach 200 millimeter outside, and the air value is also automatically calculated. On the right side of the page we have other parameters, and the first one is about how many millimeter we want to open the machine after that we have reached the bottom dead center. The second value is the theoretically power in ton that the machine needs to reach to obtain the desired angle. Crowning, there is no crowning. SCT is the delay time that there is between one bend and another one. This because the customer can set to wait 10 seconds before he put again the plate in the machine, because maybe the one before is very big and it needs to take time before the excesses goes in the front position. SCP is the pinching point correction. So this means that, for instance, we write 1 millimeter, but your plate is 0.8. You need to correct this value in plus or minus to obtain the real pinching point, to avoid the problem to fall inside the machine before that we finish our Z form plate. Otherwise we get a collision if we have not set a zero clue. CSP is the mute point correction, that is the point that we can modify between fast and slow speed. It can go also to positive and negative as the customer desired. Holding time is how many seconds the machine needs to stay at the bottom dead center. And yeah, this is the compression, and this is the speed of the bend the machine needs to reach, the speed of the machine needs to use to reach the angle. These are some functions that are disabled. This is how many times we want to repeat the cycle, and this is an indication about the direction of the plate regarding the bend, because the customer can decide by itself to give a name to each side of the plate, and then through this parameter can recognize in which direction you need to put it between the tools. And RI is an index which is giving influence to the calculation of the excesses. This is to reach the best value, the best correction to obtain the wanted dimension. So how we make a new bend with this right arrow? I just creating number 2 with the same main data, but with everything on 0 on the center of the page. So we need to write that we want to bend under 20 degrees, for instance, and we want to reach under 20 with Terogloop, with the excesses. We don't want Terogloop. Correction is automatic, and also the calculation of the RX is automatic. The same of the rest of the page is the same of before, and if you need something you need to do it. Just touch one of the parameters and all the description are in English described. Through the menu button we can insert a step between another one. So if I want to create a bend number, a new bend number 2, I just press this button and I have the possibility to have a third bend that takes the place of the number 2. And I say angle also here, X dimension, the bend is ready. And what also we can do is copy a step. We can make a copy of a step. So we have the number 2 and the number 4 that are the same. 2 because I have copied a bend that was already created instead of another one. So yes, put the copy at the last of the program. What to say more? Yeah, in the moment that I wanna make a new band, but we know that is a mistake, here we have a button with the Gaphic draw it, and it automatically delayed. What to do? Press the menu button, and with 0 up slan out, we can give a number, but also a name. So this example name now is the list of the program, because with this button, with the paper and the discs, we get the list that is charged anytime we make a new program and we give a name. Every time that we don't give a name, we can use the program only if we don't delete it, but anyway it's not saved. And if we need to save it, we must give a name. So about programming, I also want to introduce you the way how to make a graphic program. You need to go before to the program analyze, and through these two buttons you can decide to define a new numeric program or a new graphic, like in my case. And then I say, okay, I have a piece of 1000, thickness is 1, material is 42, standard the strength of the plate is 42, and the matrice, I want to choose this one. Then the stample, I choose this one, and yeah, it's enough, and I can set OK. I can press OK, and now I can make my drawing. The first blue line is referring at the first piece of my drawing. I can't touch it because standard is 20, but I can modify under 20. And now I touch the angle, that is the next thing that the program wants to do, and I can move a 45 degree, or like in the next segment that I'm gonna do, press the buttons, and then I wanna set minus 120. And now I touch again the angle, and yeah, I make 120. And now I want to go back to modify this angle with the arrows. I go down, and alpha, that is 75, I modify 120. This is an example of a product, and now I want to make a calculation. So I press bracket, and when I see that the tools are configured other way, I can press optimization, and then when he say that is ready and there are no mistakes, I can press the number 3, that is recording, and through the simulation I can also see the way to make my program. In this page I can have some indication about how big need to be, how long it need to be the plate that I need to bend, how many time I need to turn it, and how many time I need to rotate it. And every time that I am in the bend, I can see what I need to do. I need to turn it for the second time, but it's not what you see in automatic because it's a little bit different. Okay, now we know how to make a numerical program, a graphic program. We know that when we start the machine we need to be in hand, that the machine needs to be a little bit down and not totally up to make the reference, because the mirth of the line scale is totally in the top. So like any synchro press brake need to go from the top to the end of the stroke of the cylinder, up direction. And now we go to make a new tool. To define a tool, we can press new section, and we must give the standard the main dimension, that is the braid. In my case is 80, and the 80 ohm. And now I have a main drawing about the shape of my tool. So I can start, I can say the first line is 30. Then I plug in a V die, and I have now the main dimension of this V die. Alpha, that is the angle in the die, is 85. And the V is, in my case, is 20, accepted. The radius 0.5, and this is very important, it's the ton per meter. In my case is 100 tons per meter. It's important to remember to fill it up, otherwise the controller will not tell to us that the tools can go broken before a brand. If we set the right ton per meter parameter for each tool, we will avoid any damage about tools in the machine. Any mistake can be avoided. But this is of course something that is the operator will to take care. Okay, then we go to make the next side, that to reach 80 need to be 30. Then we touch the angle alpha, we want to go down, and the height of the tool is 80. Then we go left, and this also is 80 because it's squared. Then we go up, and one is the last line, what is remaining to close the drawing. Then we press salute technique, and then this way it goes correctly to finish the shape of the tool. When everything is ready, we press menu, offline out, and then we call it fast tool. Okay, now I go in my list and of tools. I go in my list of tools, and I can see the drawing that I made with the main dimension, and of course it can be also multi-V, and for each line I can see which V I am enabling, because I can insert all the V that I want, and will appear here a list, and then it's from 1 to the number that we need, and you can select it also through the program. When I want to modify, for example, test 2, I press it a little bit, then I can see the program, the drawing again, and I can go to modify everything that I need. You can move it, so then you can see that the line is moving. Okay, now we go to make, you see, first one time it appeared the try list, second time appeared the sample list. When I want to make a new sample, I can choose between 4 models. I start from the first one. I give you, this is the total dimension, and this is what I need. That is back to the tool supporter till the end of the tool. So the total O is not important, it's just an indication. The reference O is important, is this side of the tool, from the support to the end of the tool. So I have a tool that is long 70 in this case. 100 I will not take care. Now, okay, there is a kind of demo piece that we can accept. We can modify as we want, just for dimension and for the graphic side. What is very important also here is that we set the radius, and also here the top of it. This is very important for the reason of before. If ton per meter is wrong, you are gonna risk to don't have any indication on the screen that the power that the machine is required is more than what the tool can support. This is the type number 1. If I press tool number 2, I can modify a shape of two snake tool, and with number 3 is S-shape sample, and number 4 it's around tool that we can modify. So